32%. Didn't last long. Neither did anything else. Okay, oxygen about 21% basically. Argon just about 1%. Carbon dioxide at 0.03. And that's not much. And just a small change in that changes the planet a hell of a lot, just ask the people on Venus. Okay. A couple other things about air, interesting, that are non-intuitive. It's heavy. Actually, you'll see down along the bottom, in John's old store, I calculated the mass of the air in his store. 1,800 pounds. They walk into that store, here's your inside a hobby store, there's almost the weight of a small car in there. It's 2,000 pounds of air in there. People confuse that.
We got a bar at school, it's an inch square,
Yeah.
and it weighs 16 pounds, that's atmospheric pressure in pounds per square inch.
Yeah.
And so you hand that to somebody and say, set this on your toe or whatever. It's pretty amazing that you don't realize that's per square inch.
But people confuse air pressure with the mass, and I say, look,
Right.
take the atmosphere away from the Earth, so it's just like the moon, but with our gravity. Fill up a box with air at the pressure it is here in Zeno, and it'll weigh 1,800 pounds. So, but the other things are, so it's massive, and the illusion I give is, okay, you don't think 30 miles an hour is very fast, because we get into things like turbulators or surface roughness. And what happens there, and I'll show you a picture of this, I'll do it in a future thought, or talk. Well, let's go back to the 1930s. Guys used to make these beautifully done little balsa gliders, and they'd get in contests. One of the things they noticed was that after you were in a few contests and the airplane got beat up a little bit, it flew better than it did when it first came out and was all shiny and polished. And they eventually figured out, and today we can show it happening, they figured out the science that the flow over the surface can easily separate into big clumpy globs. And in fact, in most of the cases, when these little airplanes slow way down, the airflow over the surface separates or breaks off and just flops around. But by putting a few little notches or discontinuities in the surface, you cause the air up front, where it's relatively energetic, to turbulate or to swirl. And that makes it mix. And when it mixes, it stays closely attached to the foil. So the airfoil with the little micro flaws on the surface, like any kind of a pattern. And that's the secret of the golf ball, of course. The dimples create that kind of a surface and cut the total drag down. Anyway, that's another whole talk. But anyway, I like this picture. You probably figured that out. Okay. Thermals. This is the typical sketch of a thermal. And the idea being that sunlight warms the ground or warms the air, and then the warm air rises, and it rises in a turning column, creating like a donut-shaped top, and eventually it spills out of the top, cools off, and comes down near the ground. And in general, it's pretty accurate. I mean, in general. But it has its problems. There are two common misconceptions. One, that thermals are always toroidal with donut-shaped tops. And actually, in fact, that doesn't happen often. But I got a beautiful picture of one here that did in a minute. And the second theory is that thermals rotate in only one direction, counterclockwise in the northern hemisphere. Well, hurricanes and really large storms do. But thermals, no. They're pretty random because they're real small mass and they're affected by the Coriolis forces very small. Here is a real toroidal one that somebody got a photograph of from an airplane, and it's amazing. It's looking down on it. But a real toroidal thermal. They're rare, but sometimes they happen. You know? But we don't often see them over the flying field. Okay, now this was the early partially correct idea that most people are familiar with. You get, let's say you have a typical field. You have some breeze going across it, very light, the air is moving along across the field. Sunlight warms up the field, the air gets warm and goes up into a thermal updraft, like a column. And usually they tell beginners, hey, this is what you want to find. You want to find one of these rising columns. Well, you're not often going to find a column, actually, but you'll find something else. And by the way, the column kind of drifts because it stays with as much as it can with the prevailing wind. As the warm air starts to rise, the moving air carries it with it, so the thing tends to lean over. And sometimes I notice, I put this little down, potential breakaway at the tree line. What happens if the whole column slips across the field and hits the tree line? Well, then it starts to separate from the ground. So anyway, that's kind of the general view that people are first given. But I want to give you a slightly different view. This is a little more accurate. Here's your grassy field. Sunlight is coming in. There's a little bit of breeze moving. Now the sunlight comes in, and it actually doesn't warm the air. The sunlight warms the ground. But in the infrared end of the spectrum, that warm ground broadcasts back. And air absorbs infrared like nuts, and it warms up. Okay, so that reflected infrared, or the ground heat, warms the air. Have you ever wondered why? Shit, there's sunlight forming right here, but it feels warm up here. And it's because it's actually the infrared re-radiation coming off the warm ground. That warms the air, and it doesn't take much warming for that stuff to start to form and start to move up. And I've drawn this intentionally because it looks almost like it's going to break off. And in fact, it usually does. It usually goes up as a lumpy, as somebody succinctly put it, thermals look more, new thermals, near the ground, where they're coming up and just forming over a field, look more like dog turds in the air than like any kind of a pattern you can imagine. And it's a true statement. It's really true. Now here's a little different view of that thing happening. Here you can see one forming, one that's gotten over by the tree line and sort of broken off. So it's kind of like this thing moving up, and another one's breaking off and moving up. And you see the guys, especially with DLGs, they'll say, hey, it's breaking off over the tree line. As this is happening, as this thing is stumbling over the tree line, the leaves are all starting to rag around. And the smart guys like Gavin and stuff are going there. Boom! And they go out beyond that tree line and above it. And you'll say, you'll never get your plane back. Boom, and up they go. How many times have you seen that at the field, right? That's what's going on. That happens usually when the wind is from the southwest at our field and breaking over the toilets where it gets added energy from, never mind. All right. This is backing up for a second and looking at like the whole county or a section of the county or a couple of big farms. What goes on is you'll get these lumpy thermals, these circles or dog turds in the sky moving up at various places. But the warm air tends to move up fairly quickly, but it's in kind of an ocean of cooler air. But for all the volume that goes up, an equal volume has to come down. So if you're not in lift, you're in sync. It's very low sync, but in general, most of the sky we fly in is in sync. You get out there on some day and you're flying up there, there's no lift. Well, you're right. There probably isn't right there. But someplace there is around there, if there actually is sync. Otherwise, the air is not really going down through the ground, which it feels like it's doing some days. But anyway, that's another problem. But anyway, so if you look at the sky, just a cross-section of it, the areas where the air is warm and going up comprise a smaller area, generally, than the areas that are cool and slightly going down. But these areas that are going up are more energetic. That is, they're moving up faster than this area is moving down. So the total volume, of course, stays constant over these cubic miles of air that move over us all the time. Does that make sense? It's something I had never really thought about until I saw a couple of articles on it. Let's see, what do we got next? Oh, okay. I want to go back and we're going to do a kind of a review because there's a guy on the web that did these little sketches and they're so damn good that I just love them. These are old. These go back, these are from 2007, but this Bill Barr who put them together, I think the original drawings go way back beyond that, into the 50s somewhere. But again, he's showing thermal formation, growth and rate, same thing, different direction,
sunlight warming the ground, the warm air, the ground warming the air with it. He doesn't explain that it's infrared moving back, but nonetheless, the breeze coming down. But the point is, here's the model. He feels a breeze. What's he doing? He's sitting there on the field wondering where the hell the lift is. He doesn't realize, okay, you're standing on our field at the crest of the hill. He doesn't realize that out there or on the field beyond us, that is starting to happen. There's a bubble coming up. Okay? So the thing starts to bubble up. And it's bubbling up. And we're standing there and saying, hey, the breeze is let off. What's going on? Well, that's because there's a bubble in front of us. And our feeling of the breeze is it's calmer. Shit, what's going on? Well, you know the way of the prevailing wind. You're standing there looking at the southwest of the field. You know the wind is coming up that way, or it has been blowing that way, let's say. And all of a sudden it's getting calm. That means there's something coming. And just point your hand about 45 degrees out, and you're probably you want to go search that way. And then the thing continues to be calm, and the thing continues to grow. If you're lucky, it gets burly like this. And again, if you've got a discus launcher and you're throwing it up there, and all of a sudden you pull one of those stunts like Steve does, where he'll go out there, say, I'm not feeling it. Oh, there it is. Whoa! And up she's going, you know. You're like, how do you do that? And then finally, the thing will let go. And you'll get a little poof of air as it comes in underneath it. And a lot of times, guys, you'll see the good pilots will think, oh shit, it's breezy. And the good guys are up there going, kapow! And they're going up. And you say, why are they going up? I've done this myself a lot. But they're up in the poof and you're down on the ground, you know. And for guys that don't have a good launch height like me with discus, this poof ball goes up here and I launch and I can't get into the bottom of it. But if you do, you get a hell of a ride. Okay, this is a picture of a simulation or a reconstruction of radar data over the open ocean. And they were doing this over the ocean because it's a consistent surface and there are thermals over the ocean. But this is what thermals on a larger scale look like. And I should have put the scale on here. This, I think, is 1,000 feet. But I could be wrong on that. But I think the vertical scale in this was 1,000 feet. So these are real low-level thermals. And notice their shapes. They don't look anything like we tend to picture thermals. But they are roughly, you know, like lumpy dog turds in the sky. But like if you were flying and you came along and caught the right signals from your airplane and turned out of it, nope, turned into it, oh, hey, there's something here. You get yourself a pretty good ride because those are going up faster than the stuff around it is going down. When thermals really get energetic, you get these guys. We don't have them here much, although we have had some. Bob Belger tells the story of some contest he went to in the old free flight days when they had the big old 1930s jobs. And some guy's airplane got lifted right up off the field and flew away. Okay. And on a larger scale, thermals tend to form what we call bubbles in streaks. You know, the bubbles will come off of a warm field. There'll be one, the cooler air will come in, another one will form, it'll come up, they tend to form bubbles. And in a lot of places, they'll actually agglomerate into like lines of columns, and they call them streaks. And this is obviously from a full-scale tow plane going up, but you can see the thermal streaks clearly, and we've seen this kind of stuff in the sky. So, anyway, it's just, they're there. Thermal formation, the free flight guys know. They've got all this crazy equipment that measures the ground temperature as it changes. And you can measure the surface temperature of the ground as it changes, and they don't measure this, but they do measure this. You'll see the free flyers come out with their little poles and their thermostat and their little recorders. And it's going up. You know, we're not talking big changes in temperature actually, but they measure those and they know damn well when things are down here and starting to move, it's time to launch. So anyway, I share that with you, the thermal and so anyway. Okay, A few simple rules. You can't see these things. A few simple rules. All of them, actually, I said most, but all of them are based on the fact that your airplane and other guys' planes can read thermals. They absolutely can. So, before your flight, study the field and the prevailing wind. Spot surfaces likely to warm quickly, or surfaces you suspect, where you've seen soaring birds or stuff. Look for seeds, dust, fuzz, or anything else going up. Look for flying insects of any type, or the birds that feed on them. A lot of times you'll see these little fleets of birds coming in, moving around. They're eating insects. Those insects are going up in thermals. Watch for the soaring birds, the hawks and vultures and seagulls. They're a little more our scale. And set out ribbon poles, which we do, and watch experience violence. Biggest secret in this game is the smartest guys on the field are the guys who want to fly near. Couple last, I'm getting down towards the end here. I've only got a couple of basic things, but these are the real, where it gets, push comes to shove. When you're flying, if you're flying along and there's a thermal ahead of you and you fly into it, there's something forming, there's air flowing into that warm air as the warm air rises, there's inflow against the rudder, but the main thing is, the air towards the center of the thermal is moving up faster than air out here. So it tends to want your airplane to tip slightly. So the signal you're looking for is you've got a plane that's set up in trim, you know you're in a normal state of trim, she's clocking along, and all of a sudden, for some reason, she wants to go right. Watch it for a minute. When you're sure that's a good effect, crank left. Crank into her and see what happens. See if you can pick her up. And more often than not, you'll find if you get a nice signal, you crank into it, and by gosh, all of a sudden you're on an elevator. Just keep turning, because they're usually not real broad. But just keep turning and take what you can. You're doing like a circling flight, and you find that on one side of the circle you go up, on the other side, keep opening up into that side where you go up. Let the thermal tell you where it is. And you just, okay. So, that's the bad news. But, and I've seen this in a contest. I've seen guys like, what's his name? Oh, he builds your kind of airplanes. He builds these big, Tom Scully. He won the Toledo show 2 years ago, or the last 2 years, with big homemade gliders. And anyway, Tommy's great at this. Those big gliders don't respond real well to, let's say they're getting pushed out. You try to give them a rudder turn, let's say turn left to get into the thermal, can't do it, don't fight it. He cranks right, pulls up elevator, and boom, boom. Put one of those things on its wingtip, come right around and come right into that thermal, boom. In other words, he'll do a 360 and come into it, boom. And when he comes into it, ass end goes up and away she goes. He's good at that. If you miss it, you don't make it, but you haven't lost anything, Okay. The other thing that happens is when you're running into a thermal, when you're coming along like this and you're running into faster moving air, the plane will tend to loft its tail. And it'll tend to look like it's kind of doing this. Now, on the other hand, if you're driving along and all of a sudden she seems to slog like this, and beginners get fooled. They say, oh, my nose is up. It must be going up. No, it's not. It's going down. Tail's going down, and you're starting to enter sink. Get the hell out of there. That's an important one to think about. That's easy to think about, but hard to do. When you see it, you can swear to God it's going up. When it's got the tail down, and it's just not doing it. And I think I have another. Yeah, this is the one that's best to read. And one thing discus launch has helped me a lot with is this. Because with a DLG, even the little shit, you can catch it. And it's good. That's the only thing I've gotten good at in DLG. I can catch those little guys and sometimes do a war with them. And I do okay. But launching and stuff, that's another matter. Okay. And then this is highlighted. Attitude changes going in and out. Watch the tail up effect. You're cruising along and the tail comes up and the plane seems to get energetic. You're in a winner, baby. Don't keep driving through it. Start turning slowly. And if you turn left and it
all of a sudden you say, where did it go? Just sweep it right on around and come right back into that area you were in. Because they usually, one of the things that's kind of non-intuitive, you'll be standing on the ground. The average wind speed will be, let's say, 7 miles an hour. But the ground air, because it might be cold air filling in something that's moved past you, might be at 10 miles an hour. But so you think everything's roaring by, but it's not. The greater mass of air is still moving along at 7 miles an hour. And that thermal out there is too. So it'll move downwind from you, but not as fast as you might think from feeling it on the ground. So you can get faked out by ground airspeed, because ground airspeed is not what the airplanes do. And the other thing that people do that if you think about it, the more you think about it, the more silly it sounds. But we always say, oh, it's windy up there. You know, no, there is no wind up there. Once you've launched your airplane, you're not in wind. You're sitting in a mass of air, which is traveling along. So you're just flying. And as far as your airplane is concerned, there are just areas that go up that are warmer, and areas that go down that are colder. Now you're drifting along. The airplane knows nothing about ground wind. So don't worry about the wind. You're standing on the ground, you're feeling this stuff blowing past you, saying, oh, the wind is, I can't turn. It has nothing to do with it. You're doing something wrong. The airplane will turn fine. It's just drifting down with the wind, and it doesn't look like it's turning. But if you've given it a turn command, you can see it, an aileron turn. But sometimes with a rudder, you get faked out. She turns. So anyway, think about that when you're out there. That's a mental one. So, anyway, that's the basic pitch I'm making. Read the airplane. Get up there, watch the airplanes for signs of lift. The big one really is to go out there, and I gotta tell stories on myself. I used to go out there all the time, and I like to bullshit. So I'm always standing around talking. But then it dawned on me one day, the Tom Scullys, the Gavins, the Oligs, the Jim Thomases, they're going out the field. Good morning, Barn, how are you? And they're looking out at the field, because they're seeing what Joe Schmatz is running into out there. You know, and they're thinking to themselves, you know, Schmatz just got a good ride over there. Why is that? Oh, yeah. Oh, the wind is from here. There must be something up that way that he's riding on. And they're thinking, so when they go out for their first flight, when I go out for my first flight, I go, oh, this is the first flight. Let's see what happened. When Jim Thomas walks out for his first flight, he's saying, I know where the air is. But he's looking real serious. He's not telling anybody. Everybody's going this way. Thomas, right there. He saw it. He knows where it is and where it's going to be again. That's why he's Jim Thomas. And I'm back there, and all I've got to say is, ah, frigate. Anyway, so that's my talk.
Good. Thank you.
Good. That's okay?
Yeah.
You think it'll fly?
Yeah.
Okay.
Yeah.
All right.